Nitric acid is one of the important acid known in the field of chemistry. It's also known as aquafortis and spirit of nitre, highly corrosive in nature. It's also a mineral acid as it is derived from earth crust, not from living organism, and its synthesis was being first recorded by alchemist Jebin in here. The formula is HNO3 and the molar mass 63, density 1.51 gram per centimeter cube, and the boiling point is 83. It's a very strong acid with suffocating and pungent odor, and it is corrosive to metal and tissues because it can react with them. Nitric acid is also present in acid rains. Now question arises, now how it is a part of acid rain? The exhaust from the vehicles, or you can say the byproduct of the combustion from vehicles, add oxides of nitrogen to atmosphere, and the oxides of nitrogen to atmosphere forms nitric acid with water vapor present in atmosphere and forms the acid rain and comes back to the earth's surface. It is prepared by the reaction of nitrogen dioxide with water, and the production of nitric acid is commercially also being done by oxidizing ammonia to nitric oxide in presence of platinum as a catalyst at a very high temperature, and the process is known as Ostwald process. So Ostwald process is the controlled oxidation of ammonia in presence of platinum. In this chapter, we'll further study more about nitric acid. Nitric acid in lab can also be prepared by the two saltpetters, potassium nitrate and sodium nitrate. The reaction with concentrated sulfuric acid, the byproduct is potassium hydrogen sulfate and sodium hydrogen sulfate respectively, along with nitric acid. So here the vapors then further being condensed, and these are stored by cooling into light yellow liquid. Now question arises, now why they are not light color yellow liquid? The light color yellow liquid is due to the presence of oxides of nitrogen to it. The different oxides of nitrogen are present, especially nitrogen dioxide, because nitric acid is unstable to heat and light. So due to the presence of oxides of nitrogen dioxide, it is yellow in color, and it can be removed by bubbling dry CO2 through the yellow acid. Excess of water just dissolve the excess of NO2 and gives transparent color to the dilute form, but in concentrated form the acid is yellow in color to the presence of nitrogen dioxide. As nitric acid attack rubber cork, so only glass apparatus is being used for its storage. We cannot use rubber cork because of its reaction. HCl cannot be used instead of H2SO4 since nitric acid carry HCl vapors. So this is the reason HCl cannot be used instead of sulfuric acid for its preparation, because it will carry volatile HCl vapors, and if the reaction temperature exceeds 200 degrees Celsius, then sodium sulfate is being formed, which will form a thick crust on the glass apparatus. This is the reason temperature is maintained less than 200 degrees Celsius, so that the glass apparatus should not be damaged, and nitric acid get also decomposed due to the presence of sodium sulfate. Now the properties and uses of nitric acid. Nitric acid is considered to be fuming acid due to the presence of nitrogen dioxide, which continuously evaporates. Its highly corrosive substance. It can form blisters to the skin. Molecular formula is HNO3 and the density is 1.51 and the boiling point is 83 degrees Celsius. Freezes at minus 42 degrees Celsius to form a white solid. Pure nitric acid only exists at minus 41 degrees Celsius in the form of snow white crystals, which further decomposes on liquefying into nitrogen pentadioxide and water. Passing current of dry air through this liquid removes the presence of nitrogen pentaoxide and leaves a colorless liquid 98% content of nitric acid. Further, with the physical and chemical properties of nitric acid will be discussed. The very first is oxidizing property of nitric acid. Nitric acid is a very powerful oxidizing agent. It reacts vigorously with metals and non-metals, and it can also be used as an explosive preparation. Oxidizing property is because of release of nascent oxygen which is being formed during the decomposition of acid. Nitric acid itself decomposes to give oxides of nitrogen and nascent oxygen. So this presence of nascent oxygen gives us an explosive property and also makes it strong oxidizing agent at itself decomposes in both concentrated and dilute form to give nascent oxygen. Nitric acid reacts with metal to form oxides of nitrogen, NO, N2O and NO2 or ammonia which further reacts with nitric acid to form ammonium nitrate depending upon the concentration of acid. Now let us discuss in which form it will give which oxide. In dilute form it generally forms NO, and in concentrated forms it gives nitrogen dioxide. But all the metals do not give the same. There are exceptions. Manganese, magnesium and calcium give hydrogen gas when they react with very dilute form of NO3, because in very dilute form NO2 get dissolves in water and it do not give further explosive reaction as we have already discussed. So this is the reason in very dilute form nitric acid gives H2 with only these three metals, manganese, magnesium and calcium, further showing its oxidizing property with further in the, you can say, concentrated form or slightly more dilute form, it will not give the same reaction. Nitric acid, as we have already discussed, is an oxidizing agent. So with magnesium, manganese and calcium it will give hydrogen, but with other metal it will give oxides of nitrogen, NO2, N2O or NO. It is a colorless liquid. Commercially it is yellowish brown in color due to the presence of oxides of nitrogen. As soon it decomposes to give oxides of nitrogen, and it is also forming fuming acid because of the presence of these vapors. It is soluble in water, corrosive in nature because it can cause blisters on the skin, and when oxides of nitrogen dissolves in water it forms acid rain. Now coming to the chemical properties, it is stable, but on exposure to heat, as already discussed, it will give oxides of nitrogen, NO, N2O or NO2. So presence of NO2 gives the yellow color to the acid in concentrated form. It is acidic in nature. Why it is acidic in nature? Because it gives H plus ions in aqueous state, and it is monobasic because of the release of only H plus. It gives red color with blue litmus, pink color with methyl orange, with phenolphthalein no change. General reaction with base, it will give neutralization reaction like potassium oxide with nitric acid gives the neutralization reaction giving salt and water. Same with carbonates and bicarbonate, it will give salt, water and release of CO2 gas. The general reaction with metal sulfide will give sulfur dioxides, metal nitrates and water. With metal sulfides it will give hydrogen sulfide gas in dilute form and concentrated form both. Less reactive metals like copper, silver, mercury, lead gives NO with dilute form, and zinc gives N2O with dilute form. Ammonium nitrate with very dilute form. So once again, nitric acid with less reactive metals gives nitrogen oxide, and with zinc it forms dinitrogen oxide, but with active metals it gives nitrogen dioxide. So here the various reaction. It also reacts with non-metals because of its oxidizing property. It oxidizes non-metal also into their oxides and itself get reduced to NO2 and NO. Uses: nitric acid is having a wide use in drugs and dyes industry. It has also been used in the explosive trinitrotoluene and nitroglycerine, as well as the picric acid, ammonium nitrate, calcium nitrate as fertilizers, which is also being prepared by nitric acid. It has also been used in the purification of silver and gold and an oxidizing agent, and major use in the pickling of stainless steel and preparation of rocket fuels. Its chemical doping agent property gives us the semiconductors used for raw carbon nanotubes. At low concentration, nitric acid is often being used as an artificial age pine and maple. So here are there few uses with this nitric acid is being completed.